I was thinking about physics again, or more specifically about innate physics, if that's the right term for it. Maybe like folk physics, I don't know, maybe like, no, I don't know. Innate physics, the kind of, what assumptions do we make about the physical world pretty much the minute we come into it, or do we come into the world with assumptions about the way the physical world operates? I mean, I know there is some evidence that we do, if not it coming kind of preloaded into the operating system of our brains, then something we acquire very, very, very early on, really easily. I know there's been some experiments done with babies and very young infants into this. I can't remember the names of the researchers, I'll try and find it out. Elaine something. Okay. But they basically built a series of experiments. These two are people I'm thinking of. Built on the principle that babies and infants spend more time looking at things that are unusual, to give more attention to things which break some kind of physical law or break expectation. You know, they get bored very easily. If something's expected, they get bored, they look away, but if something is unexpected, they look for longer. And the researchers have used that property, that fact that babies look longer at unusual things, in order to test what a baby's expectations are. Because obviously if you set something up, a little physical demonstration, and everything goes according to plan, everything goes as the baby would expect, then it's bored, doesn't look at it. But if you set it up in a way that contravenes expectation, then the baby looks longer, and then you know what their baby's expectations are. I remember reading about one to do with support. So if you show like a table or something like that, picture a table with an object on the table, the baby doesn't really look very long at that. But if you move the object so that it's hovering in the air just off the edge of the table, you know, like things do in cartoons, you know, when people run off the edge of a cliff, they kind of hover in the air a bit. If you show a baby a picture of that, then it looks longer at that picture than it is if the object was on the table, because it's breaking an expectation. If it's only partly on the table, like hanging over the edge, then the baby has no problem with that. It's completely expected. It's only when, as I say, when it's suspended in the air, that the baby's expectations are confounded. And now what that says is that sorry, that train's going past right now. What that says is that a very young child either comes into the world or very soon acquires a little bit of information there about physical laws to do with gravity and to do with support and that kind of thing. I mean, it is slightly different to a more mature version of it, because if you even if it's just like touching the edge of the table, this object, even if it's just touching the edge in a way that couldn't possibly happen in real life, then apparently a baby will continue to not be surprised by that. It's only when it's actually detached from the table and appears to be hovering in mid-air, like a platform game thing, but that a baby is actually surprised by that. But as I say, what that suggests is that there is an innate physics, an innate grasp of certain physical properties of the world, and that's not the only one. There's lots of different physical properties that's being tested, some of which, as I say, are the same as mature ones, and some of which do change slightly with age. It's been tested with animals as well. I can't remember what the procedure is to test with animals, but it is apparently possible to test expectations with animals, with some animals. And I know they've been done with dogs. They have a slightly different set of innate physics working with them. I can't cite the references. I'll see if I can find them. But they expect something slightly different to humans. It's been done with crows. Apparently their innate physics is a little bit closer to ours. They do instantiate something like Newton's laws of motion, for example, which babies do. Dogs don't quite do that. And I know it's been tested with primates, and again primates are quite similar to humans, as you might expect. So all that suggests, as I say, that we do have some kind of built-in instantiation of rough rules of thumb, at least, if not laws of physics, which prepare us very early on for living in a world that seems to conform to those guidelines. Go on, Phoebes. Yeah. I mean, I'm mentioning this just, I guess, in support of the idea that we do have these structures and we rely on those structures for a lot of our intuitions, and we never completely unlearn them. I think there's quite a lot of evidence to suggest we don't completely unlearn them. And in the same way that, you learn a language when you're a kid. And when of course, yes, you can learn second languages when you're older, and third languages and fourth languages. But unless you learn your second language really early, you can never really get that second language. There's always a little bit of translation going on behind the scenes. And it's the same with physics, I think. You are either born with or very quickly acquire a version of physics. And yes, of course, you can learn other physics. And you can get very, very, very fluent in other physics. But it never completely erases the innate physics that you come into the world with, I don't think. And I wouldn't be surprised, as I've speculated on a few of these videos, if that mismatch between the innate physics of a baby's brain and the educated physics of or just the more complicated physics that you run across when you're out in the world, I wouldn't be at all surprised if that mismatch is, at least responsible for part of the strangenesses that we have in our lives. Hey guy. Turn this camera off, hold on. Can't remember. Oh yeah.